Okay, so we started from the simplest case, y is equal to 2x proportionality, and then now we got the slope-intercept form by adding 5. Okay. So first y equals to 2x, then next y equals to 2x plus 5, and then I want to introduce another form for the linear function. Then as you have seen, the important thing for the slope is the proportion or rate is always equal to the constant value, which is 2, rate of change or slope. So for example, you can view the first one as y over x is equal to 2. Okay? So this is exactly the meaning of slope. Okay? So this time, for example, just going back to this one. So suppose the initial value is missing, for some reason, and then you know a couple of values here, and then the slope, but suppose you don't know this. So now, how do you get back the initial value out of this data? So you can still use the idea for this, the proportion here. Then the way you can do is this. So for example, let's look at this value here. So suppose you know the 311. Then so this one is, so you don't know. Then so what you can do is you still know the slope is 2. So for example, pick any value like this. Then call this x and y. So this is x, and then this is y. And then this time, so let's look at this triangle here. So if you have originally, so this is the situation. So you start from just a 0, 0, and this is x and y, and then the rate is always equals to 2. Y over x is equal to 2. So then that is equivalent to y equals to 2x. So that's the simplest example. So I want to use this same idea for moving this triangle to there. So this time, what is this length here? So this is y. Now this one is, it's not 0. So this is 11 here. So that's why this length is now is y minus 11. So it's a difference between the two numbers. On the other hand, this length is, now this is 3, and then this is now x. So what's the distance between 3 and x, or difference, which is now, this is x minus 3. So that's why now I want to apply this idea to the new length of this triangle. So namely, so let me go this way. So instead of y over x, so now I have these two triangles to be y minus 11 over x minus 3 is now equals to 2, which is the slope. So like you multiply the denominator to just to move this one to here. So I multiply both sides by x minus 3. Then what do I get? So I have now the y minus 11 is equal to 2 times x minus 3. And then now let's check this is really equivalent to, because this is what I studied it from. So let's check it. So is that really same as that one? So you have to use algebra. Y minus 11 is equal to 2x minus 2 times 3 is 6. So using distributive law. And then how do you solve this one for y? 2x minus 6 Then to cancel negative 11, so you have to add 11 to both sides. But remember, I would recommend you to use shortcut. What is the shortcut? You move this from left to right. What do you have to do? You have to change the sign, right? So negative 11 now is changed to the positive 11. Then now you combine these, then you get y is equal to 2x plus 5, and then which is exactly same as because that's what I studied. Okay, so of course, so as we expect, so you get the same thing. Okay, so that's why just starting from one point, okay, and slope, then you can get back the initial value, okay, as well. So this form, I just use the specific number, okay, as a slope and the point, but the general form is written as, I can replace by the general constant, okay? So let me use y naught, then x naught. So this is the formula of the line whose slope is m passing through the point x0, y0. Okay? So this is called point slope form. And then just to make sure, this is really the most general one. As a special case, if both are 0, then you get the original form for this proportionality, right? And then if only this is 0, okay, then you get y is equal to, well, if I call this, it doesn't matter, but if I call y0 equals to b, okay, so rename, then I get y equals to mx plus b, which is the slope-intercept form. Okay? So that's why this actually just includes the previous two. Okay? So that's why this is the most important one, okay, so far. Okay.